Hello, good day everyone. You're welcome to our channel. In this tutorial video, we shall be exposing you to operations with salt. I believe we are all familiar with this, and as many that are yet to have a familiarity with this particular subject, I want to assure you that we'll be taking you through the step-by-step explanation on how to solve problems regarding salt. Without wasting most of our time, we have that numbers that can be expressed as ratios of two integers, e.g. a divided by b, where a and b belongs to a set of integers and b is not equal to 0. Such numbers are called rational numbers. Example of rational numbers are 3, 2 over 3, 3 over 2, 2.7, etc. Other numbers, however, can be expressed as ratios of integers. Such numbers are called irrational numbers. They are irrational because their exact values are not determinable. Only the approximate values can be known. Example of it is pi, just like we know pi to be 3.142 and so on and so forth. We know that I want us to just understand something about surds, that surds are irrational numbers. They are the root of rational numbers whose values cannot be expressed as exact fractions. So examples of surds are root 2, root 7, root 12, etc. We'll be going straight to the rules. There are rules guiding us when it comes to the operation with surds. Alright, and one of these rules that I want us to know, there are about 4 basic ones. And rule 1, it has to do with the product. You have two numbers multiplying each other or being expressed as products of one another under a root form. You can be expressed, you can simply split them into, for example, rule 1 is saying that root PQ is the same thing as saying root P multiplied by root Q. Rule 2 is saying that when two numbers are adding each other under the umbrella of a root, you cannot express them by adding them separately. No, that's wrong. The same thing is applicable to the negative. But when it comes to division, when they are grouped under the same root form, they can be split into two, into a numerator and denominator respectively. Alright, so I want to just explain certain things to us. I want us to really see something about this root, about the rules. We've talked about the addition. We talked about the subtraction. We also talked about the multiplication as well as the division. All right, so very quickly, the rule is saying that when we have PQ, that is the same thing as saying P multiplied by root Q. All right. So a good example of this is if I have 8, for example, 8 is same thing as saying 4 times 2. So the rule is saying that I can simply say root 4 multiplied by root 2. That's what the rule of multiplication is saying. You can, when you have two numbers under a similar root and multiplying each other, you can simply split them such that you can have square root of 4, which is 2. Of course, square root of 2 is 2 because it's irrational. You can't have their exact value. All right, so this is what the first rule is talking about. The second rule is talking about when you have P plus Q, they're saying that it is not the same thing. It is very wrong to say you can split them this way. What do we mean? For example, if you have 9 is adding to 16. The rule is saying that it is wrong for you to say root 9 plus root 16. No. It is wrong for you to do this. It is never correct. Because we may be tempted to say we want to split it because we can see vividly that root 9 and root 16 can give us a perfect number such that we can say this is 3 multiplied by, sorry, this is 3 added to 4. And we are going to say, oh, this is 7. No, we are saying this is wrong. You can't do this. You must understand that. So rather, the only thing you can do here is to add these two together. It's possible to say 9 plus 16, that will give you 25. And then you see, when you take this, when you take the square root of that 25, what happens? Square root of 25 will now give us 5. You see that the answers are not the same. So that's what the rule is saying, that whenever you have an expression of additions like this, you have to be careful not to be tempted to split them. The same thing is also applicable to the negative sign. When you are having the negative in between them, for example, root 9 minus 16, he said it is wrong. It is very incorrect of us to say it's same thing as root 9 minus root 16. No, they are not the same thing. It's never the same. So when you do this, he says it's not the same thing as saying 3 minus 4. You know, it's not equal to negative 1. You see, this is not correct. It is never correct. So the rule is saying that we should not try this. Then the fourth one is about the division. It's saying that, for example, if I have 16 over 9, I can equally say and split it to say 16 divided by root 9. Yeah, this is allowed. You can do this. This is very possible. It's going to have the same answer as 4 divided by 3, which is a very good one. So when you have this, don't forget you can split them into something like this, where you'll be able to have a proper expression, and then you can simplify as further as possible. I believe we're understanding these rules. There are 4 basic rules, which there is no way you will not encounter such when we are dealing with operations of sort. So it is important for us to have this idea of what we are talking about. All right. Also, I want us to also understand what we call the basic forms of surds. So we said that root p is said to be in its basic form if p does not have a factor that is a perfect square. So thus, root p will only be basic if root p cannot be broken down further into 2 factors where one of them has an exact square root. For example, root 2, root 7, root 5, root 3 are in basic form. However, root 18 is not in its basic form because it can be broken down into root 9 plus 2. 9 times 2, which is equals to root 9 multiplied by root 2, which is 3 root 2. So we can say that 3 root 2 now is in its basic form because the root form can no longer be broken down further into any other two factors, which is you can have a root form. All right, so let me just highlight a little thing about basic form. Basic form is very, very important. You can't solve, in fact, most of the solutions in surd operations, our answers are left in basic form. So it is important for us to understand what this basic form is all about. Now, when we are dealing with basic form, what you are looking at is the root form. For example, if you look at 9, now you will now check. Oh, no, 9 is even very easy because it has a very easy square. You can easily say the square root of 9 is 3. Okay, but let's look at something like 27. Is 27, is root 27 in its basic form? You will check. This 27, can I get 2 factors? In other words, you remember what factors are? If I say what are the factors of 27, I'm simply asking what are the numbers that can divide 27 without a remainder. So that's what we mean when we talk about factors. So I will now check this 27. Is it possible for me to get 2 factors, that is 2 numbers that can divide it? And it will be such that one of them must not have a perfect square root. So we are talking about 2 factors that can divide a number, and one of them must not be a perfect square root. It must not be a number that we can take the square root perfectly. For example, when we talk about perfect square roots, we talked about numbers like 9, like 4, like 16, like 25, like 100. All those numbers are numbers that have a perfect square root. So we are going to check. If I want to say root 7 is in basic form, then I must not be able to see two numbers that can divide 27, such that one of those numbers will be that none of them is a perfect square. What do I mean? For example, numbers that can divide 27 here, I know 9 can do that, you see, and 3, in fact, 9 times 3 is 27. So you see that one of these factors is 9, which happens to be a number that has a perfect square root. So I can now say that root 27 is not in its basic form. Why? Because I can still see another factor inside this particular that can divide 27 that is having a perfect square root. So we say that root 27 is not in its basic form. All right, so if I look at another number like 15, is root 15 in its basic form? Then I will check what are the numbers that can divide 15. I know that 3 can divide 15. I know that 5 can divide 15. I know that 15 can divide 15. So you see all these factors that I've listed. Is there any of them that has a perfect square root? No, there is none. So I can say that root 15 is in its basic form. You see, it's basic. Basic because I can't get numbers like that. So I know that's how we know if a particular surd is in its basic form. We can also have root 3 over 2. What we check for is the root side of it. You don't put your eye on what is already out. We look at what is inside this root form that I'm seeing, which happens to be our surd. You know, the representation of surd, we look at this very representation and we check this, what is under this umbrella of this square root. Is it possible for me to have two numbers that can divide it and one of them will have a perfect square root? If yes, then it's not in its basic form. If no, then this particular number is in its basic form. I believe we are understanding what basic form is. It is very, very important we put our minds to understanding what basic form is all about, because all solutions in sorts must be expressed in its basic form. And that's when they ask you to simplify, sometimes what the examiner is simply asking us to do is to just express that particular sort in its basic form. So I believe we are enjoying this video. I believe we have learned one or two things regarding this. So we'll be taking series of examples, questions that will expose us to more knowledge and also understanding on how operation with sword is all about. I believe we are going to enjoy this. Please stay tuned to our channel. Please subscribe, share, and like. And I assure you that you will be able to, you will have fresh understanding of every of the mathematics topics we'll be bringing up to you. We are going to start step by step from scratch. Even those that are not having interest in mathematics will begin to love mathematics as you stay tuned to our channel, because this is the mandate that God has given to us. We are here so that we can eradicate corruption through education. So that's why I'm imploring us to please stay tuned to our channel. Just continue to watch, like, and subscribe as we bring bit by bit problems concerning mathematics that everybody, our agenda is that we want everybody to be able to be a lover of mathematics. So I believe with this explanation about basic form, we understood what basic form is all about. Just don't forget that when you are talking about basic form, once again, you are simply looking at a number that must not have any factor that happens to be a perfect square root. Okay, if that is there, so if that is taken, then you discover that that will not be a problem. All right, so let's go to questions. Let's solve how do we apply all this, and I believe we enjoy this video. Thank you very much. As we go to the next aspect of solving questions regarding operations of sort. All right, we are welcome. So we shall be looking at first and foremost these two questions to point to us what we have explained earlier, from here you can see that the examiner just asks us to simplify root 240. Right, so how do we engage in such an expression or simplification such as this? Okay, so the first thing, just like we said, we can see clearly that we check this root form. Is it in its basic form? In other words, can I get any factor that can divide this 240 such that one of them will be a number with a perfect square root? If yes, then I have to take it to this basic form. So obviously it looks as if 240 is not in its basic form unless otherwise proven. So we are going to check. Now, this is the idea I want to sell to us. Since one of the factors that, one of the rules is that this number must not have any factor that has a perfect square. So if I look at factors from 4 and I keep going to downward this way, I can see 4, 9, of course 16, 25, you know, I can see 25. After 25 we can see 36. Okay, these are factors, these are numbers rather that are perfect square root. So what I will do is this: I will try to start using any of them to be dividing this and see if any of these ones can be a factor of 240. You know, just like I told us earlier that factors are numbers that can divide another number without a remainder. All right, so factors of 240 will be numbers that can divide 240 without a remainder. Now, because what we are trying to do, we are trying to avoid perfect square root numbers, you know, to still exist in a particular given root form. So what we are going to start doing is like a try and error, because we are still starting. You start trying to see among all these numbers, okay, which of them can be a factor of 240. So when we are able to get one, good, then you will now see that from there we go to the next step. All right, so let me just bring up my calculator and let's just give a trial to this. If I say 240 divided by 240 divided by, for example, 4, okay, equals to 60. So I can see 240. I can see 240 divided by 60. That gave me so I can see let me just say, okay, 240, the two factors I can see is 60 times 4. All right, so let me try now. Obviously, you know, from our divisibility rule, 9 will not work. Okay, but let's just see, since we are still learning. So 240 also divided by 9, you see, it's giving us decimal, so that will not work. So let's try another one. 240 divided by 16. Okay, that's 15. Yeah, this is good. This is good. 240 divided by 16, that's 15. Okay, so we also have 240 divided by, so I'm also going to have 16 multiplied by 5. So your answer that you left after dividing it, the answer that the calculator is giving you is what you will use to multiply what you have divided that very number with. So just like what you have here. So now, why did I move further? Because when I saw this, I saw that this 60 is still very big. So there is tendency of still having another number inside it that can have a perfect square. So that's why I went further to say, okay, let me try other ones until I'm able to see 15. I know that 15 cannot have any other number, any other factor that can have a perfect square root. Yeah, I can see that. So that's why I'm comfortable with this. So what do I do next? So what's to write now is now, okay, root 240 is simply the same thing as saying root 16 multiplied by 15. All right, so from our rule, we said that we can split it. So root 16 is the same thing as saying root 16, root 240 is the same thing as saying root 16 divided by, multiplied by root 15. All right, so when we do this, we are going to have 4 multiplied by root 15. Okay, which is the same thing as saying 4 root 15. So it will not more, it will just stay outside this way. All right. So we can see that this is how to solve this. We started by trying an error, trying to use these perfect square root numbers as factors to divide a given number in a particular expression, and that will help us. So whenever you are able to get a good one and you see that the answer that the calculator has given to you is not a number that can be expressed, that can have a factor that is a perfect square, then I think that will do the job. That will definitely do the job. So all you need to do is just to go ahead and express it. Now look at this one. In this case, we are looking at 98. So of course, I'm going to try it again and say 98 divided by 4. Okay, that gave me to see it's giving a decimal, so it will not work. So we also have 98 again divided by 9. Okay, that gives us decimal, it will not work. 98 again divided by 16. Okay, that's also not working. All right, so can you see it's also not working? So we also have 98 divided by 25. 98 divided by 25. That's also not working. Can you see? All right. So we also have 98 divided by 36. It's also not working. Good. So you see, I like this scenario that we are having. So sometimes you will see that all your factors are not working. So one of the things you will quickly do is to, sometimes from experience we discover that it's good to just use 2 to divide it into 2 first and see. If I divide this thing into 2, will it give me something reasonable? So now let's try this. You will now have 98 divided by 2 is giving us 49. Can you see? So this is an exposure. You see now that we are able to have 49. And what happens? 49 happens to be a perfect square root. You see? So I don't mean you will continue anyway. Let's assume you continue from 36. You check the next one. 49. You see, we will have gotten it. But another way to, like a shortcut, is try and divide by 2. Sometimes dividing by 2, that number by 2. Of course, if it's a number divisible by 2, you'll be able to give you you can get a clue on how to move ahead. But it's good, you see, as we are trying it, you can see that we are actually progressing. So what can we say next? So we can simply say that root 98 is the same thing as saying root 49 multiplied by 2. You see, the target is to get a factor that is a perfect square root. Okay, so and the root say is the same thing as saying root 49 multiplied by root 2. All right. So since 7 times 7 is 49, so we have 7 multiplied by root 2. Okay, which is same thing as saying 7 root 2. So you see now, I check these 2. I saw that no, I can't have any other factor. Of course, 2 is a prime number, right? Okay, and we are saying that of course it's not if I can't get any other factor of 2 that such that one of them will be a perfect square. No, I can't get that. So you see that we rest our case. So it's already in its basic form. So we are true. This also is also already in its own basic form. So we will leave our answers like this. You must ensure that before you will leave your answer, they must be in their basic form. This is very, very important. So don't forget the idea we are starting, because as you get exposed to them, later you start understanding, even without any need for you to be dividing like this. You start having an idea, okay, this is what I will do, this is what I will do. But because we are searching for factors that is a perfect square, that's why we are dividing any given expression by all these numbers that happens to be perfect squares. I believe we are understanding what we are doing. So these are potential numbers. So you can list as many as possible. You can list as many as possible perfect square numbers, perfect root numbers that you can use to keep dividing until you get one that is no longer divisible, or that cannot produce any other number that is that has a perfect square root. So I believe we are understanding this. It's very important for us to to put this in at the back of our minds. It's very easy to take any sort to its basic form. As far as you understand these rules, that just search for factors that has a perfect square root, and that will do the job. All right, so let's look at some more questions as we proceed further. Okay, so these are other questions. We have simplify root 150, and on my right side, we also have simplify root 72. Okay, so without wasting time, let's just get down to this. Okay, so how do we solve problems like this? It is very important we know how to solve problems like this, just like what we have been doing. Don't forget we have our secret factors that we can keep. Remember them. We have our 4, we have our 9, we have our 16, we have 25, we have 36, and so on. We have 49, and so on and so forth. So now the first thing we check, what are the factors that I can have that can divide 150. Okay, from our divisibility rule, we see that numbers that end with 0 can be divisible by 5 and 10. So very easy. So that's why sometimes that idea will just help you to quickly go and check 25, because since 25 is also having 5 at the last, so these are multiples of 5 thereabouts, so that may also help the work. So let's just quickly check 150 divided by 25, so that you'll not be guessing and be wasting time. You see, we are able to get 6 immediately. So so that's what we do. So what do I do next? I just say 150 is same thing as saying root 25 multiplied by, what was that, our answer? We're able to have 6, and 6, of course, cannot give us two factors in which one of them will be a perfect square root number. So no, so that means we are good to go. All right, so we have the root 25 multiplied by root 6. Okay, of course, this is root 25 is 5 multiplied by root 6, which is same thing as saying 5 root 6. Okay, now is in its basic form. Can we see? This one is in its basic form. All right, so let's look at 72 also. What are the numbers that can divide 72? Let's see. 72 divided by 4. Okay, that's giving me 18. You see, I like this. Let's just use this. I like this. It's giving me 18. I want to show us something about this. We have that root 72. When we divided it, we had 4 times 18. But you see, this 18 is obviously it's not a number. It's still having something inside it. You see, that's why you don't stop. You don't stop. So it's same thing as saying 4 times. I know that 9 times 2 is also 18. So you see, you don't stop your division, or you try as much as possible to look for numbers such that by the time you multiply, at least one of them will be a number that can no longer have a perfect square root. Those are the two factors we'll be looking for. One will have a perfect square root, the other will not have. And no matter how, it will not have. So that's that. When you're able to get those two factors, then you are good to go. All right. So this one simply means root 4 multiplied by root 9 multiplied by root 2. You see, that's the rule. Even if they are 10, you can split them out like this. So which is the same thing as saying 2 multiplied by 3 multiplied by root 2. You see now, what do we have? This is 6 multiplied by root 2, which is 6 root 2. I believe we are enjoying this video and we are gaining understanding. So these are, the more you solve, the more experience you are going to keep getting. Let's look at some other questions. Look at this. Of course, very obvious. We can see that 25 times 2 will give me 50. So you see, as we keep solving, you'll be having the experience of what to do. If you are yet to move as fast, you can still keep on dividing them by perfect square root numbers. Then you will see that you'll be having a progression as you go with time. So this is same thing as doing this. All right, from our rule, you say that it's same thing as saying root 25 multiplied by root 2. All right, when you do this, you are going to have 5 multiplied by root 2, which is same thing as saying 5 root 2. You see, it's that easy. This is 100. You see, 100 is also obvious. root 200 is also very obvious. It looks as if it's something easy for us to do. Why? Because I know that 200 is something as saying 100 times 2. You see, all this, there are some that will be very obvious, that staring at you at the face, and you'll be able to know what the two factors will be. One of the factors will be a number of perfect square roots, while the other one will be the one that does not have a perfect square root. So those are the two factors we are always searching for. All right, so this is actually root 100 multiplied by root 2. Okay, so what do we have next? This is going to give me 10 multiplied by root 2, which is saying 10 root 2. Did you see this? That's how to do it. You make sure that you are looking for factors. Our search is for factors, and these factors must be, it can be 2, it can be 3, but just make sure that you are able to have numbers with a perfect square root, then another one without a perfect square root, that does not have a perfect square root. So these are numbers that you'll be searching for. When you're able to get any of these factors like this, it can even be just like in the case we did before. It can be, dependent, but you are able to get these two. Wow, you have just like the one we have solved here. You see, this one has a perfect square root. This 2 does not have. And in the case of 25 has a perfect square root, 2 does not have. So you see, this is how you keep on going. All right. So look at another question too that I want to expose us to is, how do we take an expression to its single surd? It's like the opposite of what you are doing. When you are expressing a surd expressing a surd in its single surd, you are actually doing the opposite of taking it to its basic form. So we normally express, for example, this particular one that we can see here is already in its basic form, but we are asked to take it to single surd. All right, so what do? You simply return back what is outside. You return it back inside. All right, so what do I mean by inside? These two will go back inside this root form, and when it's going back, it will return back as its perfect square root number. For example, 10 was there before. As 2 will be going, this 2 as it's entering, you will square it. So that's 4. So 4 will now return back into the square root form. So, and when you do this, you are going to have root 40. I believe you understand it. So if any number is going up, for example, let me just add another one. Let's assume I have something like this, and I'm taking it to a single surd. This 3 is returning back into the square root umbrella. All right. So what do? As it's going in, I square it. So, and the square of 3 is going to be 9. All right. So by the time you will write it, it's going to give you the 3 that was inside the umbrella before. All right. Multiplied by the 3 that is coming in now, and is coming in as 9. So this will give you root 27. So you see, this is how to express numbers in their surd in single form. All right, look at this one also that we have here. We have 2 root 10. All right, so we are expressing it as single surd. What do? This 2 will return back. It's going back inside. You brought it out before to express it at its basic form. Now you return it back. That's what they are saying. They are just saying, do the opposite of what you have known to be doing. Do the opposite of basic. Numbers that are already in their basic form, you are expected to take them back to the single surd, the way it was before you express it as basic. That's simply what they are asking. So these 2 came out. All right, so I will return it back, but don't forget, you must square it. After squaring it, then you take it back to multiply what is inside this the root already. So for example, now in this case, 10 was already inside the square root before we came. It was actually root 10. All right, so 2 is coming in back. So it's not going to come in as 2. It's going to come in as the square of 2. Okay, so don't just know this way, that you are going to square it, and when you do that, we are going to have it. You see, it's actually similar to what we have on the left side. So this is 40. So just for emphasis sake, that is why we are introducing us to things like this. So can we just do one more? Let's say 7 root 3. Okay, 7 root 3 to a single surd will be 7 going back into this root. So what do? I square 7, and 7 times 7 is 49. All right. So what I'm going to have the root of 3 that was there before multiplied by 49. So you see, it's very, very easy. There is no big deal about it at all. This is 7, this is 2. If we multiply this, that's 12, 13, 14. So we have 147. I believe we are understanding this. We are understanding this problem. We are familiarizing ourselves with surd operations. So as many of us that are yet to, that this is our first time, it's possible this is your first time of hearing about surd operations. So is this easy? There is no big deal. There is nothing too hard about it. It's something you can easily crack. Just follow the steps gradually, and you hit at it. All right. I believe everybody can do single sort now. So let's also look at something like this. How do we do? I'm taking it to single sort. It's going to be 10 squared, right? Which is 100. Okay. So what's this one going to give me? It's going to give me 5 that was under it before, multiplied by 100. Okay. So this is going to give me 500. Thank you very much. I believe we are understanding this, and we are enjoying the video. And we're also going to see some other questions, okay, just to give us a proper perspective of what we are talking about, so that we can gain mastery. I believe the more we solve questions, the more we get experience, and the more we gain mastery. All right, thank you for watching. Let's look at other questions as we proceed further. Okay, so we also have this question. It's simply saying 7 root 6. 7 root 6. So how do we take 7 root 6 to a single sort? We have to express a single sort, and they gave us 7 root 6. All right, so we have 7 root 6, just like we have done earlier. 7 is returning back, so it's going to return as 7 square, which is 49. All right, so we are going to have 49 multiplied by 6. You see, it's that simple. It's actually simple. 49 multiplied by 6 gave us 296. All right, so this answer is going to be 296. Is it 296 or 294? Okay, 294. All right, so that's 294. Okay, you see, that's just it. Now look at this one also. This is root 13, of course. So root 13 root 7, which is going to be, this 13 is going back. Of course, we have 13 square. That's 169, right? Okay, so we are going to have 7 multiplied by 169. You see, that's how to convert this to single sort. So we bring out my calculator now. I'm going to have 169 multiplied by 7. Okay, that's 1,183. 1,183. So you are going to have root of 1,183. You see, so this is how to take sort back to, express a sort in a single sort, maybe an expression, a given question, and you are asked to to express it as single sort. So this is basically what they are saying. They are taking that you should take it back to an expression such that you can still have the root, factors inside that is a perfect that has a perfect square root. So that's simply what we are asked to do. I believe we are with these few explanations, we are getting it. We are moving forward. All right, so let's now look at what we call similar sorts. It's very important, because when you are factorizing, you are adding, you are subtracting. Similar sorts are very, very important. So what are similar sorts? So similar sorts are actually sorts or irrational parts that contain same numerator. All right, so if you look at 3 root n and 6 root n, you see that both of them I can see root n, I can see root n. So you watch the sort form, you watch this area. this very square root umbrella is what you are going to check. Is it the same? If it's the same, for example, we have root n is equals to root n. So this is a similar sort. Look at this case. We have 6 root x and 7 root x. You see, root x is the same. So that means these are similar. All right. So let's look at another one. You see, look at 6 root 3 and 4 root n. These are not similar. Why? Because their root form is not the same. This is root n and this is root 3. So they are not equal. So these ones are not similar sorts. The same thing is applicable to 5 root 2 and 2 root 5. So you check this root umbrella. That's what you will check. Once you check it, the number here and the one you are comparing it with, are they the same? If it's the same, yes, they are similar sorts. If they are not the same, they are not similar sorts. I believe we are getting. Let's just look at few explanation. For example, if I have a number like this, for example, let's say I have 7 root 5, and I have another one that is, let's say, 5 root 7. Okay. Now, what if I want to check? I will check the root form. This is root 5. This is root 7. So are they similar? No, these ones are not similar. Why? Because their root form is not the same. What if I have 2 root 2? I mean, let's say 2 root 3, and another number as 2 root let's say 2 root 2, for example. Yeah, irrespective of the fact that these are first numbers, you know, the one multiplying the root form is the same, but that will not make them similar sorts. What will determine whether they are similar sorts must be what is written under this umbrella of this square root. So you will check the number under this root sign. Okay, for example, this is 3. Under this root sign is 2. Are they the same? No, meaning they are not similar sorts. So similar sorts is important. You know this because we can only add similar sorts or subtract similar sorts. Sorts that are not similar, there is nothing you can do. So it's like factorizing. It's like collecting the like terms that we do in algebra. You know, 2x and 2x squared are not similar. They are never similar. So you cannot factorize it. Neither can you add this together. I mean, you can factorize, but you cannot add this together. You cannot subtract them. Why? Because you cannot perform two mathematical operations: addition, subtraction. So you cannot say 2x minus 2x squared. Then you will now say you have an answer. You can factorize because you can see, okay, I have 2x common, you know, so I can say this is 1 minus x, okay, you can factorize, but just like you cannot say 1 minus x, then you have a specific answer. That's the same way we talked about surd also. So for example, if we are still going to look at that, excuse me. For example, I have 7 root 2 minus 5 root 2. Now, what can I do in this case? This is just, I'm just bringing this up, but we are still going to look this into in details. Look at this. We have root 2. We have root 2. So these two are similar. Then you can subtract them. You can subtract them. Just like if I have 4x minus 3x. Yeah. Why can I say the answer is x? I can say the answer is x because these two are similar. So I can subtract them. I believe we are understanding what similar sorts is all about. All right. So another thing I want to show us is about what we call the conjugate sorts. Conjugate sorts. Conjugate sorts are two sorts whose products result in a rational number. In an expression containing difference of two squares, it is known that, of course, x plus y multiplying x minus y is x squared minus y squared. That's difference of two squares, right? So when we now have an expression of sorts, having root like root x plus root y, multiplying root x minus root y is same thing as saying root x squared minus root y squared, which is x minus y. All right. So we used to know this, applying the the principle of a difference of two squares to this also. This is what we are going to. In this case, you are going to have it as x minus y because this root is going to go out. Hope you understand why this root is out. This from indices. Indices actually gave us this. So root x all squared is simply x 1 over 2 all squared. Okay. Product power law in indices, that is, these two products, this power will multiply each other, and when that is done, you are going to have x 2 over 2. So 2 over 2 will cancel out, okay, which is going to give you x raised to power 1, of course, which is x. So that's why we are able to have x here. The same thing is applicable to y square. When you take, in fact, when you have root 3 and you square it again, the answer will just be 3, because this root and this one, they will cancel out. Then you will be left with whatever is under the root form. So conjugate of a surd is simply this. If you have root 3 minus root 5, it's the same thing as saying root 3 plus, the conjugate will be root 3 plus root 5. If you have minus 2 root 7 plus root 3, the conjugate will be minus 2 root 7 minus root 8. In other words, what are we checking? We are checking the sign in between them. The sign in between them is what you are going to change. Once you change it to the opposite, then you have actually gotten the conjugate of that surd. Okay, I want to throw more light to this. Let's look at some example. Let me just explain something to us about conjugate of surds. The conjugate of surds is very important and very easy. So because if you don't know conjugate of surd, you will not be able to rationalize properly. Now, for example, if I have 3 root 2 added to 5 root 3, all right, if I'm looking for the conjugate of this, all I simply need to do is to check. I will just check the sign in between it. All right, I can see clearly that, oh, the sign in between this is positive. All right, so all I will just need to do is to change that sign to negative. So I have this minus 5 root 3. Okay, so this is the conjugate of this. All right, look at another one. If I have 2 negative 5 root let's say root 5, okay, and it's being subtracted, let's say they are subtracting 3 root let's say root 2 from it, and I'm looking for the conjugate of this. Don't pay attention to this one. Is the sign in between them. The sign, you see, we have 2 different expressions here, you see. So you can easily see what is the sign. The sign in between them is what you will pay attention to when you are finding the conjugate, not the sign that is in front of whether this one. Usually the sign of the second one, because this is actually negative 3 root 2. All right, so is this sign you are going to alter. When you alter it, you have successfully found the conjugate of this particular surd expression. So what's going to be the answer of this is going to be minus 5 root 5, okay, plus 3 root 2. So we say this is the conjugate of this. Let's do one more. Look at 7 root 3 plus 5 root 3. Okay, what's going to be the conjugate of this? The conjugate is going to be 7 root 3 minus 5 root 3. You see, it's very simple to do. Let's also do one more. Let's adjust for it to say, can you just try this? Can everybody just try this? Let's say we have 8 root 5 minus 5 root, let's say root 7. Okay, can we try? All right, I believe we are doing it. Okay, that's very good. Yeah, some of us are doing, we are really good. Well, we are doing a good job. All right, some just by looking at it, they can just tell us the answer. Okay, that's very good one. So what do we have? I just watched the sign. We are looking for the conjugate of this surd expression. So this is going to give us 8 root 5 added to 5 root 7. Good. So this is the conjugate. Conjugate, very, very important when we are dealing with surd operations. You know, there will be a time where we'll be asked to rationalize. And when you know how to find the conjugate of a surd, you're also able to know the addition, you know, surds that are similar. then you'll be able to add them, you'll be able to subtract them. So we have just a recap on what we have discussed so far. We have been able to look at similar surds, surds that are similar. Okay, we are looking at similar surds. We've also looked at conjugate of surds, conjugates. Okay, so very important. We say similar surds are surds that have their rational form is the same. The irrational form is the same. Okay, take for example, 8 root 5 and 5 root 7. They are not similar. Why? Because their root form is not the same. Okay, look at 3 root 2 and 5 root 3. They are not. They are also not similar. Why? Because their root form are not the same. So look at this. We have 7 root 3 and 5 root 3. Yes, I can see this root 3 is root 3 here, and also root 3 is root 3. So these are similar surds. So what about these similar surds? When the one or more surd or an expression in surd is similar, then you can add them. Like in this case, I can say 7 plus 5, which is going to give me 12, and that's 12 root 3. You see, you just add them. 7 plus these two things you are having in front, these two numbers, 7 plus 5, 12. Then repeat just one of the common root form. Okay, and that will give you the answer. So because if they are similar, you can add them. If they are similar, you can subtract them. If they are not, there is nothing you can do. You can't just leave them, except you can factorize. Yeah, factorization is possible. But that for you to be able to perform operations of positive, negative, no. All right, thank you for watching. We are going to be looking at addition and subtraction of surds even as we go further. Thanks for watching. See you in our next video.